Hearty welcome to all knowledge seekers to my channel. This is Dr. Madhusudan Rao Kadapa. In some other videos I have given solutions to some typical problems on single server queuing model. In this video also I am going to explain a classical problem in single server queuing system. Here the problem is that there is a railway yard. Goods trains will arrive at the railway yard for loading or unloading, and the rate of arrival is 24 per day, and the inter-arrival times follow exponential distribution. And service time distribution is also exponential with an average of 40 minutes. That means the loading or unloading will take place on an average in 40 minutes. Now we have to calculate the mean length of queue, average time spent by each goods train in the yard, which includes loading and unloading time, and the probability that the number of trains in the yard exceeds 5. Here we have 24 trains arrive per day, which means the mean arrival rate of goods trains lambda is 1 per hour, and the service time is 40 minutes, so the mean service rate per hour mu equal to 1.5. And for single server queuing model, the mean queue length LQ is given by lambda square by mu into mu minus lambda. On substitution we get 1.33 goods trains. This is the number of trains in queue. Next, coming to the average time spent in the yard, Ws equal to 1 by mu minus lambda. So on substitution we get 2 hours. This 2 hours includes service time also. And probability that the expected number of trains in the system exceeds 5 is given by P of Ls greater than n. The general formula is lambda by mu whole power n. So here for n equal to 5 it is lambda by mu whole power 5. On substitution we get 0.1317. So this is the probability that the number of trains exceeds 5. So with that our problem comes to an end. Now let us extend what happens if the number of trains increases to 30 instead of 24. Suppose the number of trains is increased to 30 and the average service time is 30 minutes. Earlier it was 40. So with these changes, what will be the mean queue length and what is the probability that the number of goods trains in the system exceeds 5? Now as usual, if you consider the arrival rate of 30 trains per day, the mean arrival rate per hour lambda is 1.25, and as the service time is 30 minutes now, the mean service rate will become 2 per hour. For the revised values, if you calculate the mean length of queue, which is lambda square by mu into mu minus lambda, on substitution we get 1.042, which is less than the value what we got earlier. And similarly, probability that the expected number of trains in the system exceeds 5 is lambda by mu whole power n. Here n equal to 5, so on substitution we get 0.0954. So with the increase in the arrival rate of trains and a decrease in the service time, or otherwise we may call increase in service rate, it is observed that for the given data, the probability of number of trains in the system exceeding 5 has decreased. So this is how we can solve these kind of problems. Thank you very much. In some other video I will explain some other interesting problems in queuing theory. Thank you.